Meaning of identities. Concept of identities. Do you remember what the solution of an equation is? Yes, the value of the unknown that satisfies the equation is the solution of the equation. Correct. Let's consider the equation 3x plus 1 equals to 2 times bracket x plus 1 and see what value or values of x can satisfy the equation. Consider the equation 3x plus 1 equals to 2 times bracket x plus 1. Draw a table separating left-hand side and right-hand side like this. Now, we randomly pick 5 values of x to see which of them can satisfy the equation. For example, we choose x equals to -2, -1, 0, 1, and 2. We start from left. When x equals to -2, left-hand side equals to 3 times -2 plus 1 equals to -5. Right-hand side equals to 2 times bracket -2 plus 1 equals to -2. When x equals to -2, the value on the left-hand side does not equals to the value on the right-hand side. So x equals to -2 does not satisfy the equation. Next, when x equals to -1, left-hand side equals to 3 times -1 plus 1 equals to -2. Right-hand side equals to 2 times bracket -1 plus 1 equals to 0. Similarly, we can calculate the values on the left-hand side and right-hand side for x equals to 0, x equals to 1, and x equals to 2. From the above table, we can see that x equals to 1 can satisfy the equation 3x plus 1 equals to 2 times bracket x plus 1. Actually, there's only one value of x, that is x equals to 1, which can satisfy the equation 3x plus 1 equals to 2 times bracket x plus 1. Therefore, the equation 3x plus 1 equals to 2 times bracket x plus 1 has only one solution. But is this always true? Now, let's consider another equation 2x plus 4 equals to 2 times bracket x plus 2. Draw a table separating left-hand side and right-hand side like this. Pick 5 values of x. For example, choose x equals to -2, -1, 0, 1, and 2. We start from left. When x equals to -2, left-hand side equals to 2 times -2 plus 4 equals to 0. Right-hand side equals to 2 times bracket -2 plus 2 equals to 0. Next, when x equals to -1, left-hand side equals to 2 times -1 plus 4 equals to 2. Right-hand side equals to 2 times bracket -1 plus 2 equals to 2. Similarly, we can calculate the values on the left-hand side and right-hand side for x equals to 0, x equals to 1, and x equals to 2. From the above table, we can see that all the values of x listed in the table can satisfy the equation 2x plus 4 equals to 2 times bracket x plus 2. Actually, if we substitute any value of x into the equation, the value on the left-hand side is always equal to the value on the right-hand side. Therefore, the equation 2x plus 4 equals to 2 times bracket x plus 2 has an infinite number of solutions. That is, all values of x satisfy the equation 2x plus 4 equals to 2 times brackets x plus 2. An equation that can be satisfied by all values of the unknown or unknowns is called an identity. In order to separate from equations with one solution only, we use the symbol is identical to instead of equals to represent an identity. The symbol is identical to has 3 lines, while the symbol equals to has 2 lines only. So how can we determine whether an equation is an identity? When both sides of an equation are polynomials, we can determine whether the equation is an identity by first expanding and simplifying the polynomials on both sides. If the terms on both sides of the equation are the same after expansion and simplification, then the equation is an identity. Consider the equation 2x plus 4 equals to 2 times brackets x plus 2. Left-hand side equals to 2x plus 4. Right-hand side equals to 2 times bracket x plus 2. After expansion and removing the bracket like this, right-hand side equals to 2x plus 4. Now we see that left-hand side and right-hand side are all the same. For terms of x, in constant terms. Because left-hand side equals to right-hand side, therefore 2x plus 4 equals to 2 times bracket x plus 2 is an identity. Note that we can use the symbol is identical to or identity only when the equation is proved to be an identity. Note that for an equation involving polynomials only, if the terms on the two sides are not the same after expansion and simplification, then the equation is not an identity. Consider the equation 3x plus 1 equals to 2 times brackets x plus 1. Left-hand side equals to 3x plus 1. Right-hand side equals to 2 times brackets x plus 1. After expansion and removing the bracket like this, right-hand side equals to 2x plus 2. Now we see that left-hand side and right-hand side are not all the same. For example, the terms of x, their coefficients are different. Because left-hand side does not equals to right-hand side, therefore 3x plus 1 equals to 2 times bracket x plus 1 is not an identity. Let's see more examples. Example 1. Prove that the equation 6x plus 5 equals to negative 3 times brackets 1 minus 2x plus x is an identity. Left-hand side equals to 6x plus 5. Right-hand side equals to negative 3 times brackets 1 minus 2x plus 8. First, we expand and remove the bracket like this. Right-hand side equals to negative 3 plus 6x plus 8. Next, we simplify and group in the like terms. We get right-hand side equals to 5 plus 6x. Of course, we write right-hand side equals to 6x plus 5. Because left-hand side equals to right-hand side, therefore 6x plus 5 is identical to negative 3 times brackets 1 minus 2x plus x. Or we can say that 6x plus 5 equals to negative 3 times brackets 1 minus 2x plus x is an identity. Example 2. Determine whether the equation brackets x minus 4 times brackets 2x minus 1 equals to 2 times brackets x squared plus 2 is an identity. Left-hand side equals to brackets x minus 4 times brackets 2x minus 1. We expand and remove the bracket like this. Left-hand side equals to bracket x minus 4 times 2x minus bracket x minus 4 times 1. Next, we further expand and remove the bracket like this. Left-hand side equals to 2x squared minus xx minus x plus 4. Next, we simplify and group in the like terms. Left-hand side equals to 2x squared minus 9x plus 4. For right-hand side equals to 2 times brackets x squared plus 2. So equals to 2x squared plus 4. We see that right-hand side does not contain the term negative 9x. Left-hand side are not all the same as right-hand side. Because left-hand side does not equals to right-hand side, therefore, bracket x minus 4 times bracket 2x minus 1 equals to 2 times bracket x squared plus 2 is not an identity. Since an identity can be satisfied by all values of the unknowns, by finding a value of x that does not satisfy the equation, we can also prove that the equation is not an identity. Alternative method. Choose a value for x when x equals to 4. Of course, we can substitute any value of x into the equation as you choose. This time we choose x equals to 4. Left-hand side equals to bracket 4 minus 4 times bracket 2 times 4 minus 1. So equals to 0. So why we choose x equals to 4? Because we want to simplify the calculation. Because we substitute x equals to 4, we can make left-hand side become 0. But of course, you may also substitute x equals to 1. Right-hand side equals to 2 times bracket 4 squared plus 2 equals to 36. Because left-hand side does not equals to right-hand side, therefore bracket x minus 4, bracket 2x minus 1 equals to 2 times brackets x squared plus 2 is not an identity. You may wonder, can I use this method to prove an equation is an identity? Let's consider the following example. Consider the equation x plus 1 all square equals to x squared plus 1. When x equals to 0, left-hand side equals to bracket 0 plus 1 all square equals to 1. Right-hand side equals to 0 square plus 1 equals to 1. Because left-hand side equals to right-hand side, so you may argue that x plus 1 whole square is identical to x squared plus 1. But the answer is no. We cannot determine an equation is an identity by using this method. Actually, x plus 1 all square equals to x squared plus 1 is not an identity. Let's see the following counter example. Counter example means that it's not valid. This time we choose x equals to 1. When x equals to 1, left-hand side equals to bracket 1 plus 1 all square equals to 4. Right-hand side equals to 1 square plus 1 equals to 2. This time, because left-hand side does not equals to right-hand side, therefore, x plus 1 all square equals to x squared plus 1 is not an identity. If there's a value of the unknown that does not satisfy the given equation, so the equation is not an identity. Now, let's do some follow-up questions. Question 1. Prove that each of the following equations is an identity. Now you may pause the screen and then try it by yourself. Now, let's see the answers. Question 2. Determine whether each of the following equations is an identity. Now you may pause your screen and try it by yourself. Now let's look at the solutions and answers.